Okay, so what we're going to do here in the class that we have today is just try to see the learning outcomes doon sa nakalagay sa module natin. So isang meeting lang yung allotted dito sa nuclear chemistry. So if you're going to remember, all the reactions that you have learned so far deals with the electrons. Okay. Now, if you're going to look, there are also some reaction that doesn't only deal with the electrons. Okay. In fact, some of the other subatomic particles, particularly those found in the nucleus, they also undergo this reaction. But if you're going to look at the reactions that they have there, it's very different from the present reaction that you have already know. So in the nuclear chemistry, is the study of reactions involving changes in atomic nuclei. So sa lahat ng part nung we could say atomic nuclei. And it started when radioactivity was discovered. Okay? So sino sa tingin niyo naka-discover ng radioactivity? By Antoine Becquerel. So Becquerel accidentally discovered that uranium emits a ray into a photographic glance in the absence of sunlight or other forms of energy. And a few years later, Marie Curie demonstrated that the radiation can be emitted by other elements. And in fact, he was able to discover two new elements, polonium and radium, based on their tendency to emit radiation. So if an element has the tendency to emit radiation, we call it what? Ano yung term na ginagamit natin doon? Radioactive. Okay? So if you're going to what we could learn, when you say nuclear, you learn that thing about nuclear weapons in the news. Okay? Because the Philippines is close to North Korea. So the Kim leader there, the leader by the name Kim, he always said that he had a nuclear weapon. And I don't know what you heard about the nuclear energy options that we have there in the Philippines. So I think they try to use the nuclear plant that they have there in Bataan as source of energy. So the basis of all of those reactions is fall on this what we call nuclear chemistry. So if you're going to review about the nuclear chemistry, so maybe you go back to the nuclei. So whenever we have a nuclei, okay, we write it in terms of X as the chemical symbol. Okay, C is your what? Atomic number, and A is your mass number. So if you're going to recall, the mass number is the number of the nucleons, the protons plus the neutrons in a given nucleus. Okay, now atomic number, that's the number of your proton. And you know, atomic number is usually unique for a particular element. Now, in addition to that, we can also look at the other subatomic particles that are involved in this nuclear reaction. So if you have a proton, okay, so a proton would have an atomic number equals to 1 and a mass number that is equals to 1. And if you have a neutron, okay, it has a mass number, but it doesn't have an atomic number because it's just a neutron. And if you have an electron, okay, it has a negative charge and no mass. And the other way to call an electron is a beta particle. And then you have what we call positron. So positron, we could say, is the shortened name for positive electron. So it has a positive charge, but it doesn't have a mass. Okay? And last but not the least is the alpha particle. And the alpha particle is just, we could say, the helium that you have. It has an atomic number of 2 and a mass number that is equals to 4. Okay? So if we're going to look at this, whenever we have this so-called nuclear reaction, we have to take into consideration the other subatomic particle that can participate in a given nuclear reaction. Hindi lang electron. Okay? Now, when you balance nuclear reaction, you always look at the number of the mass number on both sides and also the atomic number or nuclear charge on both sides. So what's the difference of the nuclear equation from the typical chemical reaction? So in the typical chemical reaction, whatever is our element in the reactant, you can also see that element in your product side. But in a nuclear equation, you can change, okay, the element. The important thing that you have to conserve in a nuclear reaction is the number of, okay, atomic number and mass number. So they should be, we could say, the same. So if we have this what we call reaction, uranium-235 reacting with a neutron, it produces cesium 138 and rubidium-196 and 2 neutron. So if you're looking at the mass number, you're looking at the number here. So the technique here is make sure you maintain that they are the same on both sides, irregardless of the elements that you have. So you have a 235 plus 1 give you 236, and then you have 138, okay, plus 96, so that is equals to what? 234 times plus 2 times 1, so you also have 236. Okay? Now, how about the atomic number? So you also have to make sure that the sum of the atomic number on both sides are the same. So 92 plus 0, so that's 92. And then you have 55 plus 37, that is also 92. So those are maybe the types of your nuclear equation when you say balancing nuclear equation. We will have two other examples as we go on. Now, the best thing that we can look at is, okay, here, nandito na pala. Okay, so how are we going to balance the following reaction here? So what is X? Try. So if you're going to look at this 212.84, 208.82, so 212 minus 208, that's 4. And then 84 minus 2, so that's 2. So what's X? It's either HE or yung alpha particle. Okay? So either yan sa dalawang yan, because the alpha particle is usually a helium. Now how about this one? What do you think is the atomic number of the X here? And what do you think is the mass number?
-1.
-1. Tapos yung isa sa taas?
0.
0. So anong subatomic particle na may ganyan?
Electron.
So if you're going to look at it, it's an electron or a beta particle. So pwedeng ganito or beta particle. In fact, we could say this is what? Alpha decay and this is a beta decay. Okay, so analyze. Analyze, kaya ba? So let's try to look at this table, because one of the things that you need to know is to differentiate your nuclear reactions from chemical reactions. So as I have told you, lahat ng alam nyo so far is just chemical reaction. Okay? In a chemical reaction, the atoms are rearranged by the breaking and forming of chemical bonds. So there we could say is what? A conservation of element. But in the nuclear reaction, the element can be what? Converted from one another. The elements or isotopes of the same elements, they can be converted to one another. And in the chemical reaction is always the electrons. The electrons in the atomic or molecular orbitals are involved in bond formation or bond breaking. In a nuclear reaction, lahat ng subatomic particles pwedeng ma-involve. Okay? So that's the main difference there. Lahat ng subatomic particles pwede. And then this one, in terms of the energy, reactions are accompanied by absorption or release of relatively small amount. Sa nuclear reaction, they are what we call involving the so-called tremendous amount. Kaya nga ginawa siyang source of nuclear plant or source of energy. And unfortunately, it's also used for weapon of mass destruction. Okay? And the rates of the reaction are influenced by this, and this. Temperature, pressure, concentration, and catalyst. Those factors or variables, they don't have any effect in a nuclear reaction. Okay? So if you're going to look at the main difference of the nuclear reaction, they usually involve the particles in the nucleus rather than the valence electron that is involved in a chemical reaction. And I would say they yield tremendous amount of energy compared to the chemical reaction. Okay? So, let's look at the stability. Kasi sabi ko nga sa inyo, yung radioactivity is just the emission of what we call the emission of radiation from current slide. So if we're going to look at the nuclear stability, we have to look at some stuff, okay, with regards to the element. So I think the one that we can consider here is the strong nuclear force. Okay? So sabi nila, there are certain numbers of neutrons and protons that are extra stable. And usually, these are the magic number. When you have neutron or proton that is equals to 2, 8, 20, 50, 82, and 126. So we could say those are what? Special number. Just like the, I don't know if you have discussed the so-called octet rule or the octet number. Okay, the number of electrons doon sa halogen, oh no, not halogens, the noble gases. Okay, so like the extra stable numbers of electrons in the noble gases, you have 2, 10, 18, 36, 54, and 86. So they found out that if you have this number of protons and neutrons, most likely you are stable. Okay, and also they found out that nuclei with even numbers of both protons and neutrons, they're more stable than the odd numbers. So some statements that they have with regards to this, what we call stability, are the following. Okay, so if you're going to look at the subatomic particle, they say the neutron serve as the nuclear cement. So what does it do? It's going to glue the neighboring protons together despite the electric repulsions of the positive charge. But they can only do this over short distances. Okay? At large distances, ano nangyayari? yung strong nuclear force nila become less significant. So we could say the more the protons in the nucleus, which is during for the heavier atoms, the more neutrons are needed to hold them together. So sometimes this means what? One proton, there are 1.5 or twice as many neutrons. If you observe, uh, the lower atomic number, usually 1 is to 1 yung neutron tsaka proton. But if you go at a much higher or heavier atoms, parang 1.5 to 2 times na yung number ng neutrons doon sa proton. Okay? So smaller atomic nuclei usually have the same number of protons as neutron. Makikita mo yan sa carbon. Di ba? Carbon 12, 6 proton, 6 neutron. Okay? Yung fluorine, 9 proton, tapos sometimes you can have 8 or 9 or 10 neutron. Okay? So usually, sabi nila, yung single neutron daw, it's stable. And what it do, it will convert itself to a proton and electron. Okay? If you're going to look at the reaction here, so ano yung symbol ng neutron? 1, 0, N. So they can form to what? A positive 1 here, a 1, and a 1 of the what? Proton plus negative 1 and 0 electron. Do you see that? Gets ba dito? So kapag meron ka daw single neutron, it's unstable. Ang mangyari, mako-convert siya sa proton tsaka sa electron. Okay? Pag malaki yung nucleus mo, yung electric repulsive force between proton is more significant compared to the strong nuclear force. Kasi nga, okay, yung large distances between the nucleus. So they are inherently unstable and likely to undergo alpha decay. Okay, so usually we have yung tinatawag natin radioactive decay. So kapag meron tayong radioactive decay, ang nangyayari dito, yung heavier nucleus, naglo-lose ng nucleons to becomes a smaller but more stable nucleus. And in the process, it will give either what? An alpha particle, a beta particle, or gamma rays. Okay? So ito yung mga magic number na inaano natin dyan. So nandyan yung parang explanation nila kung bakit stable yung mga to. All isotopes of the element with atomic numbers higher than 83 are radioactive, and all isotopes of technetium and promethium are radioactive. Okay? Now, so if we're going to look at the number of the stable isotopes, mas marami siya kapag meron tayong even number ng protons at neutrons. Now, let's talk about this belt of stability. Ano yung information na makukuha natin dito? In some book, they call it the zone of stability. Okay? So the belt of stability, that's a graph that depicts the relationship between the number of neutrons versus the number of protons. And that's the area where they are stable nuclei. So kung makita mo yung belt of stability niyan, itong nakaano dito, light up, yan yung mga tinatawag nating stable. Okay? And below and above yung belt stability, merong certain reaction or decay ang nagfe-favor. So kapag mataas masyado yung nitrogen to proton ratio, okay, beta decay yung nagfe-favor. Now, kapag mababa naman yung neutron to proton ratio, okay, yung positron decay or electron capture ang nagfe-favor. Okay? Because I think meron doon sa pinapatanong what is the mode of decay of radioactive elements with a neutron-proton ratio below the band of stability. So Belt of stability, zone of stability, sa ating band of stability, pare-pareho lang yan. Okay? So, too many neutrons, spontaneous beta production. Too many protons, spontaneous positron reaction. So, yan yung tinatawag nating belt band or zone of stability. Okay? So, yung mga beta decay, para mga ganito yung mga reaction niya. So, if you have a beta decay, one of the product is a beta particle. So, if you're going to look at it, it could be a decrease in the number of neutrons by 1 and increase by the number of protons by 1 doon sa product. So, you could see here, increase in the number of protons. Okay, decrease in the number of neutrons by 1. So, the overall reaction that you have is this one, which I have shown you earlier. So, yung positron decay naman, ang isang mo doon, product is a positron. Okay? And you could say that's an increase of the neutrons by 1 and the decrease in the number of protons by 1. So all you need to do is just to make sure the mass number and the atomic number are balanced on both sides. So ito yung parang overall reaction ka. Meron kang proton na nag-produce ng neutron tsaka positron. And then you have an electron capture. So if you have an electron capture, so that means nandoon yung electron mo sa reactant. And the way that you're going to look at this, meron kang proton na nag-react sa electron para mag-produce ng neutron. So it's just all the subatomic particles reacting with one another to produce the subatomic particles. And then the alpha decay that we have, this is the one that involves the alpha particle. Okay, and you can also have fission. So we discuss natin yung fission tsaka fusion mamaya. Okay, so the one that I'm going to, we could say, solve here is the radioactive decay. So hindi natin masyado inano yung integrated rate law. Now, if you have a radioactive decay, it follows the so-called first order. So, I didn't discuss about that, but I would say try to look at it. I think meron silang questions about it in the incoming module, but I will see what I can say. But I'm going to have an example here. So, in the integrated rate law, okay, doon sa ano natin, usually, inano natin siya as ganito. So ito yung sa integrated rate law. So if we're going to look at this in terms of radioactive decay, pinalitan lang natin yung A with N at saka yung K with lambda. Pero yung principle, pareho pa rin. Okay? And if we're going to look at this, so N is the number of atoms at time t, and N0 is the number of atoms at time equals to 0. And the lambda there is your decay constant, which in our what we call thing, your K is the rate constant. So pareho lang talaga siya doon. So kaya naisipan ko magbigay ng problem dito that is similar to the integrated first order, and I also put it in the assignment. Okay. So if you're going to look at the first order half-life, this is how the formula would look like. And I put there two questions. Okay. So the first question that I have here, technetium-99 is used as a radio tracer for many organs. So write a half-life, with a half-life of 6 hours, what is the amount of 100 milligram of technetium-99 remaining after 2 days? So how are we going to solve this problem? paano natin isosolve to? So maybe we can go with what? Get the K first. Because if you're going to look at here, T1 half is equals to 0.693 over the rate constant or the decay constant. So we can have here 6 R's or siguro i-symbol ko muna para maintindihan nyo. 0.693 over that one. Okay? So what do? We need to get this one. So this over 0.693 over T1 half. So what can you say about the half-life? Can we use 6R? We can use 6R. Okay. As long as you're familiar with the unit. So 0.693 divided by 6R. What is that equal to? Point 1115 per R. So what do we do next? So we follow that one ln nt over n0 equals to negative. So ano given dyan? So meron tayong ito, di ba?
2 days.
0.1155 per hour. So ano yung time? 2
2
days
days.
is equals to what? Kasi dapat pareho yung unit. So for every 1 day, you have 24 hour, right? So ito yung sa isang side. Now how about dito sa isang side? Alin yung given, alin yung hahanapin?
Or yung initial and
So 100. Tapos hindi natin alam. Tama ba?
yes. So yung N po ba is in
Yun yung amount.
Okay. Sir, kahit anong given na unit dyan, sir, grams or kilograms,
Yeah,
ganun.
you have to what we could follow that thing. So ang ano naman to milligram eh. So dapat ibig sabihin kapag kasi makakancel naman lahat, di ba? So kung ano yung unit yun yung milligram. So how do we cancel this? Para natin tatanggalin yung ln para maging nt over 100. Tapos ang mangyayari nito
E-raised to
E. Oh no. Oh no.
Ay,
Oh no.
E-raised to
Pwedeng siguro gagawin ko dito tapos times 48 na lang, right? Kasi 2 times 24 is 48. So that is equals to what? 48 times 0.1155. So raised to the 5.544. So kung kinuha ko yan, I will get, what do you get? 255. I can even transpose this one para ang NT ay magiging 100 times E raised to 5544. Ano yung nakukuha nyo?
$25,569 sir.
Tapos E times 100. Parang nagkamali ako. 25,000. Saan ako nagkamali? Alam mo kung ano yung mali? Negative siya. Di ba to? Kita nyo? Sana ako nagkamali. That's a negative. So E, 5 point E, negative 5.544. So that's
0.40.
3.9. Okay? Times 100. So I get 0.391. So it's E raised to the negative. Kasi, kita nyo to? Negative lambda times T. So ito yung sagot niya. Paki-check.
Tama.
Nagkamali ako kasi kanina hindi negative yung nilagay ko. But the answer should be negative kasi ito nga yung definition dito. Kaya? Baka lumabas to doon sa module 8 nyo, sa kinetics. I think if you answer those assignment question, it can be helpful for you. So if you want to take your quiz maybe on a Saturday, on a later day, do so. If you want to be more prepared.
Pero hanggang Thursday na lang po ba talaga yung deadline ng assignments?
Ng alin?
Yung posted sa Google Classroom.
I mean, pag ano doon, usually yun yung iniisip ko. Pero ang ano doon, pag sumagot kayo, sa ako ibibigay sa inyo yung answer key. Kasi nakiusap yung isang student from your section kung pwede mag-assignment daw na ano ata siya sa exam niya. Parang na-disappoint sa score. So sabi ko, sige, at least problem-solving type to prepare you for the quiz.
Paano po kung na-late? May deduction po kayo?
Wala, kasi ang ano nga, ang sabi nila sa akin, wag ko daw i-record para hindi kayo magreklamo. Pero I need that if ever something comes out, let's say kung gusto ko ng additional point doon sa module nyo, quizzes, meron akong pagkukuhanan. But I don't want to make it a requirement. Baka kasi reklamo mo pa sa akin. Kasi ang ano ko doon,
Sir, pwede medyo, kahit medyo late magpasa.
Siguro ang gawin natin, make sure when you submit it, you have not taken the quiz yet.
Ay, okay sir, thank you po.
Kasi naisip ko nga, sabi ko, hala, bakit Wednesday night ang ginawa ko? Tapos yung quiz nyo pala, originally is 9 to 10. Pero ang usapan namin is 10 to 11, but I think they will make it into 13. We will have a meeting later on after nung class ko. Okay? So there's another problem. So konti lang yung problem ko dito. And this is just to prepare you for the module test. So iodine has a half-life of 8.1 days. Determine the rate constant of iodine 131. So this is just a very straightforward, right? So you have T1 half. And then what do you have? 0.693. The rate constant. So you have here 8.1 days, 0.693 over the rate constant. So it's just like this. So ano yung rate constant nyo? Ito yung nakukuha ko. Per day. So this is a pretty straightforward. So just, I would say, study this type of question, especially doon sa module a, 8 na kinetics problem that you're going to take this week. Okay? So, ano yung mga uses nitong mga isotopes na to? So for the one that is, we could say, the one that has a longer lifetime or half-life, you can use it for radiocarbon dating or to determine the age of material. So you can go with the radiocarbon dating, which you use C14, or if you want to have a much longer one, you use uranium-238. Okay? Useful tong radiocarbon dating in the industry na food, especially wine. Bakit? Bakit useful siya sa wine? Mas matanda yung wine, mas mahal daw ata eh, mas vintage. Okay?
Sir, hindi po, ano,
Alin?
archaeology.
Sa archaeology, uso din yan. Okay? Yung radiocarbon dating. But if you want in the business one, yun nga, ano dito sa wine industry. So they want to see if the wine is really old. Okay? That was prepared, what, 1800? Kasi maraming peke eh. Pwedeng pekein. And then we go on this what we call the fission and the fusion. Okay? Ano yung pagkakaiba ng fission tsaka doon sa tinatawag nating fusion? So when we're talking about nuclear fission, this is just the breaking up of heavier nucleus into two nuclei with small mass number. So, tingnan mo dito. So, meron kang uranium-235, may tumamasa yung subatomic particle, mag-perform ka ng dalawang mas maliit na nuclei and some atomic particle. And in addition to that, meron kang energy na marirelease. Okay? So, the fission that you have here has something to do with what? The E equals to mass times speed of light squared. The mass defect thing by Einstein, but he didn't win the Nobel Prize for that. He's just more famous for that element. Okay? So you can have, we could say, the fission, where you can have the so-called chain reaction. So if you have a nuclear fission that is a chain reaction, it can either be a subcritical when there is an average less than 1 neutron produced per uranium-235 that is consumed. And the fission will eventually stop. Or meron ka namang chain reaction where that is what we call critical, when on the average, exactly 1 neutron produced per uranium-235 that is consumed. And then in a critical chain reaction, the fission can be, we could say, self-sustaining at the same level. Now, kapag supercritical, yung chain reaction nun, ibig sabihin, there is one average more than 1 neutron produced per uranium-235 that is consumed. And this fission can increase its rate rapidly and a violent explosion can result. Okay? So usually the way that you look at this is yung critical mass. So that's the minimum mass of fissionable material required for the generation of a self-sustaining nuclear chain reaction. Okay? So when you have the spontaneous fission, yun yung heavy nuclides mo, nag-i-split into two lighter nuclides and sometimes some atomic particle, which we could say most likely neutron. So yun yung critical mass na meron ka. Now, yung fusion naman, kabaliktaran. Okay? So if fission, you have bigger molecule, bigger element or nuclei breaking down. Yung fusion naman, okay? If you're going to look at this is the combination of two light nuclei into a heavier and more stable nucleus. Okay? So, ano yung nasa reaction dito? This is what? Deuterium and deuterium. So, deuterium is the radioactive hydrogen. And they form tritium and hydrogen. And that's the amount of energy that it releases. Okay? So you can also have a tritium reacting with deuterium to give you helium. And that's a corresponding amount of energy that is released. So I would say this is the simplest form of differentiating uh, fusion with fission. Okay? So if you're going to look at the nuclear reactors that we have, okay, usually that is a result of fission. Okay? The atomic bomb, that's an uncontrolled nuclear fission. The one that they have in Hiroshima. The water reactor that you have, okay, we could say it just serves as a moderator. Now for the nuclear fusion, the one that you have, we could say here is the hydrogen bomb. Okay, so you just use hydrogen material on that thing, hydrogen isotope. So it's really, we could say, a very, ano ba tawag dito, efficient energy. But the problem that you have there is the risk, especially the waste. And I don't know, there's an HBO series called Chernobyl, detailing how the Chernobyl incident happened before and after the event. Okay? Now, what are the usefulness of these isotopes? So some of you who might end up in medicine, it's really, we could say, useful, especially those what half life is very short. Okay, since you can convert elements from one form to another in a nuclear reaction, so it's very useful in the medicine. So you have here fluorine 18, sodium 24, phosphorus 32, potassium 43. So all of them are used to monitor our body. Okay, if you have goiter, you might use the iodine 131 to determine your thyroid activity. So you can have the technetium or molybdenum here, molybdenum 99, okay, to get what we call an imaging. And if you have your biology, I'm not sure, are you familiar with the Krebs cycle? So how do you think they were able to determine the different compounds in that cycle? They use radioactive label material. I have my own experience using that thing. So I try to determine what happened to the fate of the antibiotics when it is ingested by the animal. So what I did is I use a tritium labeled antibiotics and see what happened to it. So I monitor in each of the step of the reaction what is happening to the material. Okay. So if we're going to look with this BER, the REM or RAT, the one that they called it, because that's usually the so-called biological effects of radioactivity. So every year we absorb, okay, some amount of dosage of radioactivity. And you'll be surprised that you don't get it from the nuclear plant, unless, of course, there's a meltdown, like what happened in Fukushima in 2010. Is it 2010 or 2011? I think it's 2011. Okay. But if you're going to look at this, where do you get it? When you expose yourself to X-ray. Okay. When you open a banana, you can get some stuff there. It's radioactive, but it's not the dangerous one. Okay. The dangerous radioactive materials are the ones that are penetrating. The others are fine, as long as you don't ingest them. Okay? So the uses that you have here, they use it for food irradiation. I have a study with I have my best the science the my best friend scientist there in the Philippines work in PNRI. Okay, and we did a study where we tried to determine the effect of radioactivity in Banaba. So we tried to see how its activity, a biological activity effect. So we found out that a certain dosage of your radiation, okay, it has a what we call good effect. So the same thing here in the food. So see here, this is the one that is non-irradiated, and this is the one that is irradiated. So this is a little bit much better compared to that one. But what happened is that the dosage is so high, it can affect your texture, the taste. It's affected. And I think another one that they use radioactivity. So what's the province known for mango in our country? Is that Guimaras? So they have a problem with infestation on their mango. So what they did, some people in the I think they irradiate some of these pests. And what happened if these pests mate with another what we call pests there, they become sterile. So what it do, they mate until everyone become sterile. So they save the mango industry. So I think that's all that I have for this what we call time that we have here. So as I've told you, this is our last meeting. And if ever you're going to have some question, feel free to email me. And I don't know if I can make a request. Kung magpakita kayo, palitan nyo na lang yung name nyo. Gawin yung superhero. Kasi ipopost ko to see how it works. The experience that I have. So, ano ko yung background ko. Tatanggalin ko. Megan. Pangit kasi naikot yung electric fan eh. So, question. Before we say, hindi pa naman tapos eh, kasi meron pa kayong final exam after nung module. I'm not sure, na-schedule na ba yung final exam natin?
Not yet. Not yet, sir.
So sa Google Classroom,
wala pa naman.
Mag-abang na lang kayo ng message sa Google Classroom. Just in case. Megan, can you turn off the light? Thank you. So question. Tanong.
Sir, kung hindi po affected sa temperature, nuclear reaction. Sir, ano yung parang nag-start sa reaction ng isang nuclear reactor?
Ano
Sir,
yun?
Di ba hindi po naapektuhan ng temperature?
No. Walang effect mga yun. Yung nature ng substance lang yung kung radioactive siya or hindi. Doon lang magkakaroon ng nuclear reaction. So kapag hindi siya radioactive, wala kang nuclear reaction. So hindi ma-effect kung tataas yung temperature, tataas yung concentration. Wala. It's all on the ability or what we call the nature of the substance itself, kung radioactive siya or hindi. Yun lang yung nag-undergo ng nuclear reaction. So question. Ready na kayo for
Sir,
module?
Yung energy po na nare-release sa nuclear reaction is in terms of, by sir, electron? energy.
It has something to do with the mass defect. So, yung mass defect kasi, ang explanation nito ni Einstein, di ba ito? So, yung mass na yan, yun yung tinatawag na mass defect. So, yan yung difference, let's say, ng buong atom, yung mass ng buong atom minus yung total mass ng mga tinatawag natin subatomic particle. So for instance, let's say if we want to get the mass defect, let's say nung fluorine. So ano yung fluorine? Meron kang F, ano yung ano ng atom ng fluorine? F9 19? Diba? So, pag nagbe-breakdown yan, ano yung meron ka dyan? Megan, get up. I'm having a class here. Okay? So, if it's breakdown, what happened? It gives you 9 proton and how many neutron? 10, di ba? So, ang kukunin mo ngayon, yung difference ng mass niya ay yung 9 times the mass ng proton plus 10 times the mass of the neutron. Tapos isasubtract mo siya ng alin? Mass ng atom. So usually, if we're going to put a number here just to show you the so-called mass defect, so ito yung mass ng proton. And usually, the mass of the neutron is close to that if it's not the same. Tapos i-ano mo dito yung atomic mass na 8.9984. So you will have a mass defect of 0.1578 atomic mass unit. Okay? So ito yung gagamitin mo doon sa speed of light. So speed of light is 3.0 times 10 to the 8 squared. So ano yung makukuha mo? Since nagre-release ka ng energy dito, you get around 1.43 times 10 to the, is it 16 or 18? Just check. AMU M squared S squared, which if you're going to do in the kilogram, it's around, we could say 2.37 times 10 to the 11 joules. Maliit, di ba? Kaso, sa isang atom lang yan. Okay? So in 1 mole, how many atom do you have? I-multiply mo yan sa Avogadro's number. So the energy that you will get here is around what? To the 13 joules per mole. So that's a very big amount. Then Einstein regret this contribution. Kasi it's a very good source of energy, but it's also a good source of weapon of mass destruction. He didn't want the Nobel Prize for E equals to mc squared. Saan siya nanalo ng Nobel Prize? Anyone?
Relativity, sir.
Nope. He won the Nobel Prize for the photoelectric effect. The theory of relativity is this one. He's more famous for that,
Sir.
but he didn't get the Nobel for that. He got the Nobel Prize, I think, in 1905. He formulated this around 1920 or later. Okay? Tanong, Tanong? Handa na ba kayo sa module quizzes?